Alright, this one is pretty straightforward. We start from rest, so we start off with no kinetic energy. In other words, our kinetic energy at the beginning is going to be 0. We have our 19 kilogram mass. It's going to slide down this semicircular, well, it's a quarter of a circle. And it's under the influence of just gravity, but there is friction. There is friction. They don't tell us what the coefficient of friction is. They tell us the radius of the track, which corresponds also to the height that the block starts at. Those are going to be at the same distance, my distance being 34. Acceleration due to gravity is 9.8, and it tells us the kinetic energy at the end, at the bottom of the track, so our final kinetic energy is 3,400. And the question is asking how much work is done against friction, or what is the work done, I guess, by friction. So to do that, we need to figure out, well, how much energy did we have up at the top? What type of energy did we have at the top? Well, at the top, there was no kinetic energy, but we did have some energy. Well, what we had at the top was gravitational potential energy. And it'd be pretty simple and straightforward to calculate how much potential energy we had. That would just be mass times gravity times height. My mass being 19 times 9.8 times my height being 34. And so if I do that calculation, what I will get, 19 times 9.8 times 34, I'm going to get 6,330.8. So that's how much energy we start off with at the top, but that's not how much energy we get at the bottom. At the bottom, we only have, well, at the bottom, the final potential energy is going to be 0, but we only have kinetic energy at the bottom, and my kinetic energy at the bottom is 3,400. So those numbers don't match up. Well, where did the energy go? And the answer to that is it went to the work that was done by friction, or the work done against friction. So all I have to do is just subtract those two numbers, and the remainder, what's left over, what's missing, my 2,930.8, that's my answer.